All right, so now we get to talk about what we used in 4.3 part 1 and kind of apply it for maybe a real life situation. So I'm going to give you 3 points on a parabola, and you're going to have to tell me the equation. So just for fun, let's just sketch a little sketch. On this first example, the points are at -1, 6, so there's one there. Looks like 2, 6, so right there, and then 3, 2 would be about right there. Right, so here's what this parabola looks like-ish. Okay, that doesn't really help me a whole lot getting the equation, but it kind of gives me an idea of how to check my equation after I get it to see if it's realistic for these points. Okay, so we're going to be writing these in standard form. So just remember, standard form is y equals ax squared plus bx plus c. Okay, so theoretically, these points should work for every single equation and be true if I plug in the point for the x and the point for the y. The problem is, though, we don't know what the a, b, and c is. Okay, but that's no big deal. I'm going to teach you how to do it. So let's first start with our first point, which is -1, 6. Okay, so remember, this is the x, this is the y. So we are going to plug into that original equation 6 equals, I don't know what a is, so I'm going to leave it, but I'm going to plug in -1 for my x, and there's 2 spots where there's an x in this equation, so it would be there and there, and then of course we don't know what the c, b or c is, so I'm just leaving it. Okay, before I clean that up, which I'm going to go ahead and plug in the second point, which is 2, 6. So 6 for the y and 2 for my x. It's going to look like that. All right, and then the last one is 3, 2. Okay, so, oops, why did I put a 6 right there? I didn't mean to. So I'm going to plug in 2 for my y and 3 for my x. Okay, so now, when we were doing the systems of equations, all of the equations were looking like x plus y plus z equals 2, or some kind of constant, right? So just for simplicity's sake, because that's what you're used to, I'm going to move this whole, this section, I'm going to start with this first line. I'm going to move this over to the other side and clean it up all in the same motion. So these are going to turn into -1 squared is just 1a, so a. B times -1 is -b. Plus c, of course, and I'm just going to move that 6 over to the other side so it looks like what we've been doing on that last lesson. Okay, clean up the second one. That would be 4a plus 2b plus c equals 6. The last one would be 9a plus 3b plus c equals 2. Okay. So now we're here. So now we can do good old systems of equation. So which variable looks like it's the easiest to simplify? I would say definitely the c's, but we are going to have to subtract the equations because they're both positive. So a minus 4a would give you -3a. -b minus 2b would be -3b. The c's would cancel, and 6 minus 6 would be 0. All right, the next one, 4a, and we're going to have to subtract these because the c's are both positive. Okay, 4a minus 9a would be -5a. 2b minus 3b would be -b. 6 minus 2 would be 4. Okay, so I have options here. So it looks like I want my b's to cancel. It's going to be the least amount of work, but it's still going to be a little bit of work. So right now they don't cancel, but I'm going to have to multiply something. So you have options. I could multiply that blue equation by either 3 or -3. And I'm going to lean towards -3. That would cause their signs to become opposites, which would allow me to add the equations, and I prefer to add them if I have the chance because I think I'm less likely to make a mistake. So I'm going to multiply this whole thing by -3. So that would give me 15a plus 3b equals -12. All right, and then I'm just going to move over that red equation. So -3a minus 3b equals 0. Okay, now since those signs are opposite, we can add them. That would give me 12a equals -12. So a is -1. Okay, so we did all that work, but we're not quite there. We still need to figure out what our b and our c is. So the next variable would have to be the b. So I'm going to plug that into, let's just do the top red one. Okay, doesn't matter, but that's the one I'm going to choose. So -3 times -1 minus 3b equals 0. So this would be 3 minus 3b equals 0. -3b equals -3, so b must be 1. All right, last one, the c. I'm going to plug it into the very first one. It looks the simplest to me. So I've got -1 minus your b, so -1, plus c equals 6. Combine those like terms. -2 plus c equals 6. Add that 2 over 6. c is 8. All right, so now on this one, you're not going to write it as a coordinate with the 3 things like we have been, okay? Because that wasn't the whole point of this. The whole point when we did all that, so we can write the equation. So we are actually going to substitute those in for the standard form. We know our a, we know our b, and we know our c. So let's do it. So you could write this as y equals -1x squared plus 1x plus 8, or just a little bit cleaner, I mean, that's perfectly fine. You could write it as -x squared plus x plus 8. Okay, before we move on, that is your answer, either one of those. Let's double check. What would the y-intercept of this graph be? Well, it would be your c. So your y-intercept would be at 0, 8. Looking back at our original little sketch, does that look like it could be about 8? Yeah. Maybe my graph isn't perfect, weird. But it looks like it could be around that area. You could also use the -b over 2a to find the axis of symmetry. I bet it's somewhere right along there, and then plug it in for your vertex maybe just to see if it matches up. Another thing you could do is you could also graph it in a graphing calculator. In this class, you won't have access to that on your tests, your quizzes, but maybe in higher level classes or on the ACT, if you wanted to do that just to make sure, that's one way you could do it. Okay, another one, I'm going to go a little bit faster to try to save some time on this video. So we have our 3 points. We're going to plug each coordinate in for your x and your y to the standard form. So we have 10 equals a times 1 squared plus b times 1 plus c. And then 6 equals a times 2 squared plus b times 2 plus c. The last one, -2 equals a times 3 squared plus b times 3 plus c. Okay, let's clean it up and move those 10, 6, and -2 over to the other side like we did the last one. Again, that's not necessary. It's just sticking with what we've been doing. So moving them, so we're cleaning it up. So we have a plus b plus c equals 10. 4a plus 2b plus c equals 6. And then 9a plus 3b plus c equals -2. All right, let's see which variable looks like it's the easiest to cancel. And again, it's the c, which for this, it usually is always going to be the c because they are not ever going to have some number being multiplied. It's just going to be a regular old c. Okay, we need to subtract them, of course. So a minus 4a gives you -3a. B minus 2b is -b. C's cancel. And 10 minus 6 gives you 4. All right, the next one I also need to subtract. So 4a minus 9a is -5a. 2b minus 3b is -b. And 6 minus -2 would give me 8. All right, so looks like they're the same sign on this one. That's okay. I can subtract again, but be very, very careful because there are negatives for days. So negative 3a minus negative 5a, that would become positive 2a. Negative b minus negative b, cancel. 4 minus 8 would be negative 4. So then a must be negative 2. All right, let's plug it back in. I'm just gonna do the red one, doesn't matter. Solve for b. So that's gonna be negative 3 times negative 2 minus b equals 4. 6 minus b equals 4. So then negative b equals negative 2. So b is 2. Then the last step, plugging it into, I'm going to do that top equation. It definitely looks like the easiest. So negative 2 plus 2 plus, we still don't know c equals 10. Those cancel each other out. Sweet. So we've got c equals 10. Sweet. Now, put it all together in the standard form. So we have y equals negative 2x squared plus 2x plus 10. All right, that is it. Thanks for watching. Have a great rest of your day.